All right, next we're going to look at how to find the maximum and the minimum of an absolute value graph. And in pre-calc, you'll really talk about a local max versus an absolute max. In Math 3, we are always talking about a local max. So we're just talking, I'm not going to get into it because for this unit, it's pretty easy. And then we can talk about more complicated ones when we get into more complicated graphs. So here we're going to say the maximum is the location of the highest value of the function. Remember, when I say highest value of the function, when I say the word function, I'm talking about the y value. And I want to write it as a point. The minimum is the location of the lowest value of the function. Again, I want to write it as the point. Sometimes they'll phrase questions about maximums or minimums specifically, sometimes other things, and they'll say, like, where was the maximum located? Where was the minimum located? If they're asking you a where question, that's the location of something, and that's going to be talking about the x value. So I always write it like this. This helps me remember. I say where, comma, and then if they want to know what the maximum value is, sorry about that, and then if you want to know what the maximum value is or what the minimum value is, that would be the y value. That would be like the actual output of the function. So where is an x coordinate, what is a y coordinate, and I'll remind you guys of that. Okay, so example 5, draw an example of an absolute value function with a maximum of 3, -2. So over 3, down 2, we just want an example of that V-shaped graph where this is the very highest point. So I'm just going to draw this like perfect V like this, and that's the very highest point. There. Next, it says draw an example of an absolute value function with a minimum of your choosing. So I'm going to go ahead, I'm just going to draw it over here. I'm being fancy and I'm drawing a vertical stretch of 2. Ooh, fancy. And so here, my minimum would be -5, -4. All right, next, we're going to look at the X-intercept and the Y-intercept. So the X-intercept is where the graph crosses the x-axis. The y value, the y value always equals 0, so the point is always written as a number for the x value and a 0 for the y value. For the y-intercept, we are looking at where the graph crosses the y-axis. The x value always equals 0, so the point is always written as 0, number. Now, for these first 2 examples, the intercepts are very easy to find. The x-intercept for this one, 2 and -6. Sorry, something in my throat. 2 and -6. And then the y-intercept looks like it's 2 as well. Twice in one video, you guys. It's rough. All right, now for this next one, I purposefully chose a problem that you would have to plug into your calculator. So if you have your calculator with you, let's go ahead and clear just the memory out first. So if there's anything weird from like chemistry class or something, it won't mess with us. So I'm going to hit second, and then the plus sign, and then 7, 1, 2, just to clear everything. And we're going to have to type this one in. I put a pi in there specifically so that it would not be like this where you could just see it visually. So y equals 2. And then to get the absolute value sign, we have to hit the math button. We go over to number. The first one is absolute value. I'm going to type x minus 1. And then I need to get out of the absolute value sign, so I'm going to hit the right arrow. And then I need to type minus pi. So minus, the pi is the blue right above the up arrow. So I'm going to do second up arrow. So there's my whole equation. And now I can go ahead and hit graph. And it should look very similar to what's on your paper. Yeah. Okay. So to find the x-intercept, there are different ways that different teachers teach it, and so I'm going to show you a way, and I'm just going to be consistent, and I'm always going to find it that way. So the way that I like to find it is I go and I look at the different things you can calculate. So I hit second trace, and I find the zeros of the function. They're called the zeros of the function because they are where the function equals 0. That's why it says 0. It's where the function equals 0, because remember, y is another word for function. So zeros of the function, aka x-intercepts. Now, the calculator asks you questions. It says, tell me where to look. And you're going to give it a value to the left of the answer and to the right of the answer. Now, you can scroll to these values, or you can just plug them in. So I can scroll left and right using my arrows, or I can just plug values in that I want to look between. So my first answer is right here. It looks like it's between -2 and 0. So I'm going to type in -2 for left bound, and then I'm going to press enter. And then for right bound, I'm going to press 0, and then I'm going to press enter. Now it gives me a guess, but the guess is usually terrible, so I'm just going to press enter one more time, and then it gave me the x-intercept. So typically, if you guys get a decimal answer, I'm going to ask for 3 decimal places. So we're going to write -.571, 0. All right, now to get the other x-intercept, I'm going to do the same thing again. So second trace, option number 2. Now this time, the second x-intercept is between like 0 and 5. So you don't even have to do, like, I can see technically that the x-intercept is between 2 and 3, but you don't even have to be that accurate with it. You can just say like, the x-intercept is between 0 and 10. As long as you are choosing values to look at that are in the window of your calculator will do just fine. So if I look from 0 to 10, my calculator can find it. So 2.571, 0. Right? Now, if I had tried to do this and I said look from 0 to 11, which is just a little bit bigger than an ordinary calculator window, then my calculator says invalid. And the only reason is because my window, I'll show you, my window, it just only goes to 10. That's the only reason. So if you want it, you just have to choose numbers that are in your window. That's all you have to do. So I just want to make sure that made sense. Okay, next we want to find the Y-intercept, and so for this one, we're going to choose the x value that we want to plug in. Again, this is the same as the previous, where there's lots of different ways different math teachers do this. You can look at the table, but the way that I like to do it is I do second trace, because this is a menu and there's lots of different things you can find. And so for me, I always just go back to this menu over and over. So I do second trace number 1 because number 1 lets you plug in values that you want to find, like the corresponding y value for. So the x value for a y-intercept is 0. And so I'm going to plug 0 in for x, and that gives me a y-intercept of negative 1.142. Now, there are some students I know who hate doing it that way. They would much rather hit second graph and look at the table and find the x-intercept, or sorry, the y-intercept that way. And if that's you, that's totally fine. So I'm going to go ahead and write a note to myself here that for the x-intercepts, I'm going to do second trace, option number 2. And for the y-intercept, I'm going to do second trace, option number 1, and then plug in x equals 0. All right, next, we're going to determine with the graphs that we study whether or not the graph is continuous. And so this is something that you study in upper level math classes with more accuracy. But in Math 3, we just say the graph is continuous if you can trace the curve with your finger without picking up your finger. So most of the graphs that we study are continuous. And when they're not, they're like really not. And they're really easy to notice. So if you look at this, it's a V. You can trace the whole V with your finger. You don't have to pick up your finger to do it. It's very easy. So absolute value functions are always continuous. So the continuity for this particular unit is kind of boring. All right. The next characteristic that we're going to look at, or vocabulary term that we're going to look at, is end behavior. The end behavior is basically just describing what the arrows are doing. So, but you describe it in formal math notation. So we say as x goes to negative infinity, and we know that x as a negative infinity really just means that an arrow is pointing to the left. And we say x as x goes to positive infinity, and we know that that really just means that the arrow is pointing to the right. So what we want to do is we want to describe the arrows that point to the left and the arrows that point to the right. And in this unit, we have two situations. We have that when the arrow points to the left and the arrow points to the right, the graph could look like this, and both arrows could be pointing up. Or we have that when the graph points to the left and points to the right, both ends could be pointing down. All right, those are our two situations. So I just want to remind you that we have 4 different ways that we can write infinity. We have the infinity could be an arrow pointing left and right. So a left arrow is a negative infinity. A right arrow is positive infinity. But we also have arrows that point up and down. So we have arrows that kind of go all the directions. So arrows that go up and down. So a down arrow is a negative infinity. An up arrow is a positive infinity. So we have arrows that we think of as an x value. We have arrows that we think of as a y value. And so when we look at the arrows that are on these graphs, we think of them as a combination of the two. We think of them as facing left or right, but we also think of them as facing up or down. So here I'm going to say, as I look at the left arrow and as I look at the right arrow, and then I want to describe what those arrows are doing. Are they going up? Are they going down? Well, both of these arrows are going up. So I'm going to say the arrow goes up, the arrow goes up. So that's one possible answer for the end behavior for this unit. In this picture, I'm going to say as I look at the left arrow, as I look at the right arrow, they're both going down. So y goes to negative infinity, y goes to negative infinity. I'm looking at both of the arrows and they're both going down.